All right, hello everybody. Math lesson, May 20th, 2020. We're going to go ahead with our fluency. Number 1. To visit his grandmother, Lewis takes a train 12 and 13 thousandths kilometers and a car 6 and 37 hundredths kilometers. How many kilometers is Lewis's journey in total? So if he takes a train and then a car, we're going to just add them together. Line up your decimals. 12.013, 6.37. Remember, line up your decimals when you're adding and subtracting. You can put a placeholder here now. 3 plus 0 is 3. 1 plus 7 is going to be 8. 0 plus 3, 3. Drop that decimal. 6, 7, 8, and 1. So his journey is 18.383 or 18 and 383 thousandths kilometers. You can do km as an abbreviation if you'd like to. If you'd like to write out kilometers, go for it. Be my guest. All right, let's go number 2. Rachel, if I can fit it on the page, there we go. Well, maybe. Rachel drove 141 and 4/10 of miles in 14 hours. What was her average speed in miles per hour as a decimal? So if this says miles per hour, we're going to have the miles on the top and then the hours on the bottom. So miles per hour. So how many miles? 141 and 4/10 miles per 14 hours. We need to get this to 1. So what we need to do is just divide. So when we divide 141 and 4/10 divided by 14. All right, now we need to pop that decimal up because it's on the inside and we are dividing. There's no decimal on the outside where we need to move it over and then move over on the inside. So we just pop it up from the inside. Now, how many times can, I'll use blue. 14 go into 1. It can't go into 1. How many times can 14 go into 14? We know that's 1 time. 14 times 1 is 14. We're going to subtract. You get 0 here. Bring down your 1. How many times can 14 go into 1? It can't. So it can go in 0 times. 14 times that 0 is going to be 0. So we're going to subtract, and we still have that 1. Now we need to bring down this 4. Don't worry about that decimal. We already popped it up. So we need to bring down that 4. How many times can 14 go into 14? 1 time. 14 times 1, 14. Woo! Woo! And you subtract and you get 0. So there is 0 remainder, 0 left over. So our answer is going to be 10.1 or 10 and 1/10. And it's going to be miles per hour. So you can write 10.1 miles per hour. Or you can put MPH, that is the same thing as miles per hour. So when you're driving in a car, which you should not be yet because you have to be 16 to drive. Well, 15 and a half for your temps, I know. But do not drive. But if you look over, if someone's driving you somewhere, it might say MPH, that means miles per hour. Fun fact of the day for you all. Alrighty, well you may have known. You probably knew that, you smarty pants, but just in case you didn't know, now you do. All right, DMR, Daily Math Review. We're going to take a look at number 3. Given this expression, 9c plus 2a minus 5c, we need to simplify the expression for when a equals 6 and c equals 4. So what we need to do is replace each of these. So this c is going to be a 4, this c is going to be a 4, but this 5c means 5 times c. This 9c means 9 times c. This a is going to be 6. So 9, I'm going to write 9c plus 2a minus 5c. What you can do is combine like terms if you'd like to, or you can do this multiple ways, or we can just keep it how it is for right now and solve it and plug in what our a and c values are equal to. So if a equals 6, I'm going to put this as 2 times 6 minus 5, and then c equals 4. So 5 times 4, and then 9 times C, but C equals 4. Now, we need to multiply first. What is 9 times 4? Well, 9 times 4 is 36. Plus, what is 2 times 6? 2 times 6 is 12. Minus, what is 5 times 4? 5 times 4 is 20. Now, left to right, order of operations, left to right. Also, you will still get the same answer when you go from left to right and you multiply through. So, we finished multiplying. So, addition and subtraction, left to right. So, 36 plus 12. Well, if you don't know, that's okay. 36 plus 12. 6 plus 2 is going to be 8. 3 plus 1 is going to be 4. So, 48 minus 20. Did not do that yet. 48 minus 20. If you need to write it out, that's fine. You have 8. 4 minus 2 is going to be 2. So, our answer is 28. Bingo, bingo. You are a winner. Again, pause, rewind, whatever you need to do. All right, let's do number 4. Simplify the given expression. So, in this case, we do not have values with letters. So, we're just going to simplify. When we simplify, 6.8u, or 6 8/10 u, plus 18 42/100 a, minus 3 4/10 u, plus 62 thousandths a. So what we're going to do, we are going to look for like terms. So we need to combine like terms. Here's a u. Does anything else have a u right with it, being multiplied by u? Oh my goodness, this does. Now, when you do this, you are going to always take the operation, the math operation, the symbol, the sign, this minus here. Take that with it. So we are going to combine these two. 6.8 minus 3.4, and then we're going to keep that u. So 6.8 minus 3.4. 8 minus 4 is going to be 4. 6 minus 3 is 3. Drop that decimal in between there. So we have 3.4u. All right, we did that part. So those two are done. Let's combine the a's. So we have a positive 18.42a, and we have a positive, or add, 62 thousandths a. So we are going to line up our decimals and add those. 18.42, 0.062. And we are adding, so they're both positive, so we're going to add. 0 plus 2 is going to be 2. 6 plus 2 is going to be 8. 4 plus 0 is 4. Drop that decimal. 8 and 1. So this is a positive because it's not negative. We added and it's positive. So it's going to stay positive. So stay plus 18.482. Keep that A with it. Now, a U and an A are not the same, so you cannot combine those. Just like apples and umbrellas, you cannot combine those and say, I have all this apple umbrella things. No, apple umbrellas are not a thing, so you have to keep them separated. So this is all your answer is. 3 4/10 U plus 18 482 thousandths A. That's all you can do. That's literally it. Nothing else. All right, now let's take a look at number 5. Simplify the given expression by combining like terms. Also, what we have here, oh my goodness, we have 1/4 in front of these parentheses. So whenever we have a number in front of parentheses, remember, we can use that distributive property to simplify it. So what is 1/4 of 24? So essentially 1/4 times 24. Or if you split 24, what's 24 divided by 4? A fourth of 24. Oh, I know 6 times 4 is 24. So good, we're going to have 6, and I'm going to keep the R. Plus, I'm going to keep this here, plus 1/4 of 36y. So what is 1/4, or what times 4 equals 36? Oh, I know 9 times 4. 9 times 4 is 36, so I'm going to have plus 9y. Now that we solved that, now I can bring everything else down. Minus 2y plus 3r. Because these are not in parentheses, we can just bring them down. Now, what we can do, do we see anything that are alike? Do we have any other R's here? So I have a 6R. Do we have any other R's? Yes, we do. We have a plus 3R. So 6 plus 3 is going to be 9. 9R. 6 plus 3, 9R. Good. Now, we are going to look. We have, sorry, I should have used pink. 9, positive 9y. So it's just plus 9y. Ooh, and then negative 2y, minus 2y. So 9 minus 2 is going to be 7y. And 9 minus 2 is a positive 7, so we're going to keep it as plus there. So there's nothing else that you can combine. So our answer is 9r, or 9 times r, plus 7y, or 7 times y. That is all. Bada bing, bada boom, you're done. All right, let's look at number 6. Combine the like terms in the given expression. All right, here we go. Do we have any other t's? So I have a 6t. Oh, I have a minus 4t. So what is 6 minus 4? Well, 6 minus 4 is 2. So I'm going to have 2t. Now, what else do we have? What next? Plus a 9u. Do we have any other u's? Nope. So we're just going to bring that down as plus 9u. That's all we can do there. Now, let's use some green. Plus 6. Do we have any other whole numbers without a letter? No. Without a variable? Nope. So we're just going to keep that as plus 6. So that's all you can do there. That's your answer. Bada bing, bada boom. Easy peasy. You're done. Combining like terms. Combining the things that look alike. All right. Again, you can rewind, fast forward, but if you go rewind it and then fast forward. But rewind, pause it, whatever you need to do. All right, now we are going to look at number 7. We have 2 parts here. Number 7 for our air practice. Part A, simplify this expression using the distributive property. And then we need to combine like terms if necessary. So remember when we had our number in front of parentheses? Well, that means we can use the distributive property. So 3 times 2 is going to be 6. Keep that A. 3 times 2, 6 again. We're going to keep this plus. 3 times 2 is going to be 6. And then we have B. Minus, what is 3 times A? Just going to be 3A. Minus 3 times 9. It's going to be 27. All right, now let's combine like terms because I see that I have 2 A's. So I have 6A minus 3A. What is 6 minus 3? Oh, I know 6 minus 3 is 3. So I'm going to have 3A. Can we combine any B's? Positive 6B? Nope, so plus 6B. And then what about the minus 27? Nope, so just bring it down as minus 27. So that is the first part. That's the first part. Part B. You're going to solve this expression when A equals 4 and B equals 5. So all we're going to do, 3A plus 6B minus 27. When A equals 4, 3 times 4 plus 6 times B. What does B equal? 5 minus 27. See how I just plugged it in? I substituted it in it. Blah, blah, blah. I substituted it in. All right, so what is 3 times 4? I know that 3 times 4 is 12. I'm going to bring everything else down that we did not use yet. What is, we still have multiplication. 6 times 5, which is 30. Minus 27 plus this 12 over here. Now, when you do this, you must go from left to right. Order of operations, PEMDAS. All right, so we have addition and subtraction. So addition, 12 plus 30. It's going to be 42. Am I still on the page? 42. You can do it off to the side if you want. And then I'm going to bring down my minus 27. So now 42 minus 27. 2 minus 7 you can't do. The 4 becomes a 3. 2 becomes a 12. And then 12 minus 7 is going to be 4. I'm sorry, 5. My bad. I was like, whoa. 12 minus 7 is 5. 3 minus 2 is 1. So now our answer is just 15. Woohoo! Bada bing, bada boom. All right, let's take a look at number 8. We're almost done. I am so very proud of you all. Part A and Part B again. We can do it. We just did it. All right, so Part A, simplify the expression using the distributive property. Combine like terms if necessary. All right, so let's use our distributive property here. We have, let's do purple, 2 times 4t. So what is 2 times 4? Well, that's 8. And I'm going to keep the t minus, I'm going to keep this subtraction here, minus, what is 2 times 2? 2 times 2 is 4. Keep that k there. Plus, I'm going to keep that addition. 2 times, just not 2 times 1, because technically there's a 1 in front of this k. So 2 times 1 or 2 times k is just going to be 2k. No, not like you're gaming 2k or the year 2k or something, or 2000. Fine, whatever. So now we have, I see that we have k's. So I have a minus 4k, and then I have a positive 2k. So if you have negative 4, and then you add 2. So some of us might get a little tricky. It might get a little tricky here. So I'm going to make this a number line up here. If I have negative 4, negative 3, negative 2, negative 1, 0, 1. So if I have a number line, and I have negative 4, negative 4k, and I'm going to add 2. I'm going to get 2 closer to 0. 1, 2. What do I have? Negative 2. So I'm going to have minus 2k. And then I'm going to keep my 8t, my positive 8t here. So 8t minus 2k, I guess I could write that a little nicer. 8t minus 2k. Now, that was a little tricky. Do not stress. It's okay. Now we're going to solve for when t equals 4 and k equals 5. So 8t minus 2k. When t equals 4, 8 times 4 minus 2 times k, which is 5. What is 8 times 4? 32. Minus, what is 2 times 5? 10. 32 minus 10, let's use green. 32 minus 10 is going to be 22. That is our answer. Woohoo! All right. Also, I want to point out, attached with this lesson, I have anchor charts that are attached. So let me zoom out. There we go. Close enough. Okay, so I have anchor charts. So I have some charts just kind of showing you with one-step equations, if you want to take a look at those. It gives you some examples from what we did during the lesson. So if you need to go back or help you with your assignment today and tomorrow, you can go back and you can take a look at these. Combining like terms. So like terms are the same variables, same exponents, something like that. Here's examples. Also combining like terms with distributive property here. So you do that and then you combine them. And then we also have evaluating expressions. This one's a little more intense. It shows you each step. It also has variable or an exponent with as well as variables. So you can take a look at those. I'm so very proud of you all, and have a wonderful day.